There we go. All righty, guys. Welcome. I'm Steve Lander, Director of Pavement Management for WithersRavenel, and today's Lunch and Learn is on pavement testing for municipal resurfacing contracts. So everything here is pretty much pavement related. Hope everybody's staying safe. There's lots of stuff going around. I've picked up a cough here in the last week or so, why I'm operating from the house with a dog barking at the other end of the house. The intent of these lunch and learns is to introduce new products, new practices, broaden the maintenance toolbox, just get out there and try different things that might work for your municipality. So right out of the gate here, we're going to have 3 links that are going to be posted in the chat. The first is for PDHs or CEUs if you need those. You just hit that link and it'll take you to a form. You fill out the form, and after the presentation, you'll get PDHs, 1 PDH. There's also a link for the WithersRavenel Asset Management website, and also to a really helpful link, roadresources.org. So anything that you might be afraid to ask now, you can go and research it there. So again, we got PDHs. These lunch and learns are recorded, so if you have to step out and you need the PDHs, you can get the presentation, which will be in PDF format, and get the link to the recorded lunch and learn, and you can get PDHs that way. So just let us know. And also, too, is if you've joined us, maybe you came and you saw this on LinkedIn and you want to get on our email mailing list, we can add your email to the list, and we're not going to bug you. You're going to get 2 emails from us each month on the different topics that come up. So just let us know. And also that these lunch and learns, we try to get ideas from folks that are watching, and one of them was automated data collection. One is traffic control. And by the way, we were supposed to do traffic control this month, but it seems that our traffic control people kind of chicken out at the end. So anyway, Vlad was nice enough to step up to give us some information on the testing, but we are going to have traffic control next month. That's what I've been told, and we're going to stick with that story. So let us know if you have any ideas on things that you might like for us to give presentations on. All righty, so the way this works is that Vlad's going to be speaking for about 40 to 45 minutes, and everybody's on mute. So the way you'll communicate with us, if you have a question, is just to put it in the chat area, and we'll be monitoring the chat. If it's pertinent to what Vlad's talking about, I'll interrupt him. And what we really want to do is create more of a talking, like we're having a conversation, than just having a sheer presentation where you're asking questions at the end. So let's ask the questions while the presentation's going, and we'll see if we can get them addressed. And if we don't get them addressed in the time frame, because we've had them where there's lots of folks, a lot of questions, we'll get them answered for you after the presentation. All right, so Vlad, this is a formal introduction, has 23 years of pavement design experience. He was with the DOT in the pavement management unit for 16 years. He worked at SNME for about 7.5 years. And the focus included everything from design build projects, review, value engineering, testing for pavement structure, capacity evaluation, pavement forensic analysis, pavement drainage, pavement condition survey evaluation, and infrastructure asset management. And so Vlad joined WithersRavenel in November. So when Vlad is not looking at pavement, which he's looking at pavement most of the time, he has 3 teenagers, kids/adults that he loves spending time with, and he also likes to play soccer for fun. But according to the last outing, it might not be as fun because he was with a lot of 20-year-olds. And so I'm going to turn it over to Vlad.
Good morning, everyone. As Steve mentioned, I joined WithersRavenel about 2 months ago, and I'm most of my career has been in pavement. So I'm going to be talking about pavement testing for municipal resurfacing contracts. To give a brief overview of the presentation, here's an outline. We're going to introduce the pavement testing presentation, and it consists of mainly questions that we're trying to answer here. Why perform pavement testing? There's three main kind of factors, reasons why we want to obtain data and base our decisions on data. There was a financial related to budget, payment lifecycle performance, and constructability of the project. What information do we need in order to make these decisions regarding payment for performance, budget, and constructability? And then what actually we do decide based on the data. The overcoming challenges of existing conditions, some new methods of what can we do when we have issues on the pavements. In conclusion,
all right.
Yeah, Steve can talk about more about this.
Yeah, so basically, just to show you where we do asset management implementations across the country, everything, basically west of the East Coast is really kind of just implementation of software, not typically pavement condition surveys. So a pavement management overview, and this could be asset management, doesn't have to be pavement, but we're talking about pavement today. And Rob likes to call this the circle of success. And so, and I'll just quickly go through these components. And these were the components that Rob and I thought that are needed to have a successful program, and they have to tie to each other. So having a plan in place is vital, right? So what kind of vision do you have for your municipality? What are some of the goals you're trying to achieve? I've had clients say that they're looking to have the best, road network in the area. Okay, so what does that mean? And what kind of distresses do we need to collect in a pavement condition survey? Do we need just a 1 to 10 scale? Do we need to have severity and extent? Do we need to collect other assets? So it all starts with the plan, right? So we plan, and then from the plan, it tells us what kind of pavement condition survey we need, the treatment selection, and what we're going to be talking about mostly today, and testing. How are we making those selections? Are we just going worst first, or are we using some pavement management software to help us make decisions? So, you can have the best pavement condition survey and the best modeling software, but if you don't have good contract documents to go in the field, it's all for naught. So you got to have, each one of these components has to touch the other one, and they have to be related. And so the contract documents have to be concise to make sure that things happen in the field the way we expect. And then full-time construction inspection is a must to make sure that it gets built right. The one thing that I always think is interesting, and it doesn't matter what municipality you're at, the construction history is something that a lot of folks struggle with, and usually the construction history retires with the person who was there to do the work, or there's a plan room with all the plans and all the busted rubber bands are all busted off from all the projects that have been done. So a centralized location of when things were done, who did them, so that we can monitor how well different projects were, how they went, and so that we can monitor and change if we need. And then something that Rob and I, which, got us really interested in working for WithersRavenel, is what about the other assets? Planning your pavement projects along with the water, sewer, and stormwater just goes a long way to having a successful program. Next slide.
Thank you, Steve. So a little bit about maintenance activities. You all know after we do a penetration survey, we do get PCI scores, and this is just that standard scale that many people have seen, viewed. The very good PCI, good, fair, poor, and very poor. And I just wanted to show here that rehabilitation projects, as they come out of the PMS system, between 26 and 65 PCI, and then below 26, we have reconstruction. That's what WithersRavenel typically recommends here. So both of these activities can be included and are typically in the municipalities' resurfacing program. This is a slide that shows how the treatment selection can be, again, based on the PCI score. We look at preservation, prevent, preservation corrects, rehabilitation, reconstruction, and rehabilitation and reconstruction, a fairly large chunk of the annual budget of a municipality. Sometimes could be over 50% or even more, but they're significant part of the budget. Traditionally, municipalities in many states historically, including North Carolina, have been doing resurfacing and new and fill without much preservation. So they still continue to be a large part of the budget. What the resurfacing program does in regarding to budget is we all know that there's typically a large backlog, the payment management system, because annual budgets cannot fix everything at once. And our goal is to be able to optimize this backlog and resurfacing projects year after year. And that's where the financial part budget consideration comes. In addition, payment testing and having data about the payments that you have is can maximize the use of these resurfacing funds. We all know they're limited, and that's a large part of what data driven decisions do. In addition to monetary considerations, there's a benefit to safety for the community, which could relate to friction. There are often some segments that are known to have lower friction values and are prone to more accidents. And in some instances, there are segments where drainage could be an issue, and addressing payment testing and obtaining data about the resurfacing projects can certainly help to address these issues as well. In some instances, municipalities also really care about aesthetics, and the citizens prefer to have some types of payment treatments than other, and that's also a consideration. So I did this calculation of how much 1 lane mile of 1-inch asphalt cost at current prices. I took the a ton of asphalt to be $120, and it comes approximately at $50,000. 1 lane mile of 1-inch thick pavement. And then if we get that mile 2-lane roads, as most roads are in a municipality, the smallest ones, local roads, then we have about 100,000 costs for 1 inch of asphalt. So you can see how knowing what your resurfacing program includes, how much asphalt it needs to be on certain segments, will be a great benefit to the budget and planning. Even if you have budget leftover, you still rather know the data so that you can plan for when to put it for bid, and that suggests there's a great benefit for pavement testing, knowing the data of your pavements. The second part of pavement testing relates to pavement performance, from life cycle perspective, not only for the next CO2, as we know, but for throughout the pavement life cycle, knowing what you have as structural and functional condition at present, assist in optimization of for future performance. This stress type and extents typically derived from the pavement condition survey, and this information assists the pavement testing that I'm talking about, but this is the main information that we have from PCS, in addition to the PCI and budget requirements. Pavement performance, also pavement testing will give us information about what pavement type we have and thickness, what is the condition, including not only type of cracks as from the PCS and extent of the cracking, but also what the crack depths are. In some cases, cracks can go 1 inch, 2 inch, 3 inch down, but in many cases they can go full depth. And in another instances, your condition on the surface could be relatively good, but when you pour and when you see the layers deeper in the asphalt structure, you can sometimes see layers that are stripped out, and that can help you make a decision. That can help us engineers and municipal engineers help a decision of, can we mill that deep, and is there anything to hold the pavement we are thinking of putting on top? So in some cases, stripping in lower layers of asphalt structure will not allow some of this mill and fill resurfacing. Pavement testing allows us to see what base do we have, its thickness and condition. These are very variable, as you all know, depending on how many years it's been there, what construction has been used, or what design, and etc. Subgrade soils, type and condition can also be derived from pavement testing.
I think, Vlad, the key is here in the tagline, do you know or are you guessing? And in some places,
Yes.
You're going to need to do testing based on the type of facility that you have. It's not for everything, but it's for some, right? And when to do it, when you have real problems in the sub base, a high volume street, there's things to consider, but it's not for everything, but it is for some.
Yes, and I'm just going to give one example right away here. This is a photo of a residential street from a recent project. And as you can see, we have block cracking. It was found by the PCS penetration survey to be between 25 and 50% medium block cracking. And the PCI score came throughout the entire street. That was about 7 segments, about 61 on average, which is in the resurfacing range. And from this picture, you can decide there's no curb and gutter. However, there's a lot of driveways. And you could decide to mill and fill. Overlay probably not appropriate because you're not going to be able to match the driveways, but you could mill and fill 2 inches and think everything's going to be good. But will that mill remove the majority of the cracks? And how deep do the cracks go? If we leave the cracks, there's a kind of rule of thumb. If we mill 2 inches out of here, of this pavement surface, and put back 2 inches, if the cracks were full depth, that these cracks will reappear on the pavement surface in about 2 years, 2 to 4 years. So basically, the rule of thumb is 1 inch of fill on top of cracks prevents the reappearance of cracks for about 1 to 2 years. And we'll talk about this project a little bit later again. But here's what rehabilitation experience could be. We have our pavement section with nice curb and gutter and slopes and 1.5 inch asphalt overlay with paving the gutter.
We see a lot of.
Yes, we see that a lot in different municipalities, and it is challenging to be able always to mill and match the gutter face. So, historically, engineers pave on top of the gutter. However, what happens is when you do that, you have reduced hydraulic capacity for each overlay, and at the end, you don't have any if you go to the top. Again, another issue is ADA compliance when you overlay on top of the gutter. That also can present a tripping hazard. If you have 2-3 inches of asphalt on top of the gutter pan. And again, ADA compliance issues. Another issue is if you decide to do edge mill and just make the crown higher, you also change the slopes, so you have again increased cross slope and again more hydraulic issues with that. So if we do have originally on the original pavement section cracks and we just do overlay, these cracks, we just overlay on top of the cracks. Here's the cracks, and then our PMS says that rehabilitation is required. So currently the asphalt matches the curb and gutter. And we start overlaying on top. Even if we don't go in the pan of the gutter pan, we still go higher here. However, reflective cracks go through the overlay for 1 inch per year, approximately 1 inch per 1-2 years. If we do 2 mil fill in the same section without not overlays, because we want to match the same elevation, what happens is we remove again rehabilitation required. So we start milling, we mill down, and then we put again the 2 inches of fill to match the gutter face. However, the cracks start reappearing again in 2 years. So that was a little animation to show how both paving in the gutter pan and paving on top of the cracks, either with an overlay or mill and fill, will not solve our problems. So pavement testing. With pavement testing, we can derive a lot of data. We don't need all of the data for all situations. However, depending on the different types of projects and different challenges that we have on the resurfacing program, we can get at least basic data. So some of the data that is most common to be able to obtain is, and to really need for resurfacing making decision, is pavement thickness, and that's done through pavement coring. Pavement thickness means asphalt thickness and base thickness and subgrade evaluation in terms of type, and sometimes you even need to evaluate strengths of the subgrade for larger projects, or if there is some issues currently. So pavement cores, when knowing the thickness of existing pavement that we have in the resurfacing program, will give us, first tell us how much we need to either mill, fill, or how much do we have there. Usually it's a mill and fill because you have curb and gutter limitations. But if there's some cracking, you also may want to know how much down you need to mill in order to remove these cracks, because if you overlay on top of them, they're going to propagate really quickly. Augering is typically recommended to be down to 3-4 feet depth in order to obtain both the base and sub-base / subgrade thickness and properties. So for base, if there is aggregate base, the augering will take out the base and you can see the thickness and condition in most cases. For the subgrades, augering below the aggregate base will give you indication from visual, even without any tests. You can see the visual type of subgrades and presence of moisture, which is directly correlated with condition. So those are just basic tests for thickness and subgrade type. If there's some issues, so you want to obtain more information about the payments and base subgrade properties, there's additional tests that can be conducted, such as dynamic componentometer. This is on the right-hand side. The photo shows dynamic componentometer testing, which is conducted in the core hole with a metal rod with a standard weight that's picked up and pulled under its own weight to drive the metal rods into the base and sub-base. And the penetration per inch, or per inch typically, sometimes they do it per foot, but it's recommended per inch, is recorded. And based on that, with certain correlations, some agencies have their own correlations. There's Army Corps of Engineers correlation, NCDOT has their own correlation. You can define the CBR value, California Baling Ratio, which is a really good property to know about the soil, because based on the CBR value, you can do pavement design or estimate remaining structural life, if that is something really needed for that section. Why I'm saying that is because structural life is mostly important when there are truck or bus roads on the streets, or some larger, say, major collectors or arterials. That's where this information will come more useful, because structural capacity might be something that you want to know more about, and structural design life. In these cases, you can also obtain soil samples in the same process with the augering. You take the samples to the lab and conduct soil classification and moisture tests and different types of tests on the soil, but those are the most common. So classification and moisture, they're typically adequate to give an indication. You can also conduct CBR laboratory tests, which, if you do the in situ DCP CBR, it's probably not needed, but it's an additional information. Typically, in the existing section, the field in situ CBR value will be adequate for most resurfacing projects. If it's a new location, it is recommended to have a lab tested CBR value which is with soaked CBR, soaked soil. So this photo shows that same project that we had recently, that I showed you with the ball cracking. And on the side of the pavement, we see this in addition to some information that we received from municipality about pavement thickness. But on this photo, you can clearly see, and we measure on the field, the pavement thickness of this ball crack, 25 to 50% pavement segment was 2 inches of asphalt surface and about 5 to 6 inches of sand asphalt. If you don't know what sand asphalt is, this is a finely mixed fine mix that was common in the past in Eastern North Carolina, predominantly. Nowadays, it's not specified often, but it was a good mix in the past. However, in this case, you can see how the ball cracking that you saw previously extends all the way to the base of the sand, to the bottom of the sand asphalt. And we also verify with the municipality and from our own observation that there's no aggregate base. So the pavement consists basically of 7 to 8 inches of asphalt, which is 2 inches of surface and 5, 6 inches of sand asphalt. And the cracks go all the way through. So that was an example of if you mill 2 inches and place back 2 inches on this type of pavement with this particular distress and extent, you're basically going to delay the cracks to reflect on back to the surface by about 2 to 4 years. What else can you do here if you have 7, 8 inches of asphalt with no aggregate base underneath? We'll talk about this a little later, but it is pretty expensive to mill and remove the entire asphalt, and there's probably not even very good reason for it. Even if the cracks go all the way through, there's some other ways to mitigate that. So in this example, having information, data that was both from the utilities department of the municipality and our own observation help us to make a decision of what was appropriate for this pavement. Originally was in the resurfacing part of the pavement program, but it went to a different type of treatment. So obtaining data about subgrades such as CBR, California barrier ratio, pavement thickness, and base course thickness and condition can also help assist as inputs in pavement design. If there is a need to do pavement design based on traffic loads or just because there's some issues and pavement design would be a benefit, this data is needed for inputs. Otherwise, again, as Steve mentioned, do we know it or we guess it? What the CBR is and what pavement thickness, existing pavement thickness is. In order to do pavement design, there's a little bit more information needed, such as traffic, mainly the truck roads or bus roads, and then you can conduct different kind of analysis for different durations and use even the existing information for the pavement thickness with the coefficients of original structural coefficient by depreciating them to current condition and adding the needed structural coefficient to achieve desired required structural design life. So speaking about this picture here, this forum, with the block cracking and the 7-8 inches of overall asphalt thickness with no base, our decision based on that information and the PCS, PCI score and pavement distress was to go to FDR, put up reclamation with cement, where you can mill this 2 inches of asphalt, reclaim the remaining 5-6 inches of sand asphalt with part of the subgrade, 8 inches of FDR. That is, in this case, is enough, but sometimes you can go to 10 sometimes, or even 12 if you want to. FDR gives a lot of structure, so that's typically not needed to go that deep unless there's some heavy loads on this roadway section. But in this case, we chose to do 8 inches of FDR and put back the 2 inches of new asphalt to match the existing pavement elevation. So FDR requires additional pavement testing. If the decision is to do FDR, and once the municipality puts the project for bid and the contractor needs to do additional tests, FDR testing includes obtaining bulk samples of that material that's going to be used in the actual pavement section, pavement design section for the FDR in the right proportions. So you have to have, if you have 8 inches FDR in the pavement design, that means that if this is 5 inches of sand asphalt, your sample need to consist of 5 inches of sand asphalt and the 3 inches underneath, whatever that is. In this case, is subgrade, sand is subgrade. But if there is a base course, the proportions will be the base course and the subgrade, so that you can match these 8 inches of design FDR. The proportion is to match, and then you get FDR mixed design conducted in the lab with the goal to define what percent cement would be needed to get specific strengths of this full depth reclaimed mix. Typically, that strength requirement is between 200 and 400 psi in North Carolina. In some states, they go a little higher. But because you have cement, there's two different considerations here. If you go higher on the strengths, let's say you go to 500-600 psi, you kind of run the risk to have your pavement FDR base too stiff, even stiffer than the asphalt overlay of 2 inches, in this case, on top. And that could be a potential risk for shrinkage cracking of the FDR and potentially reflecting through the asphalt later on. So it's very important to have the right amount of cement so that the FDR base is in the range of the required strength, not lower, not higher. In North Carolina is by specifications between 200 and 400 psi, but most common is to have around 300 psi for FDR. And that typically here in the Piedmont area is achieved by about 25 to 30 pounds of cement per square yard, depending on type of soil, of course, but that's kind of the typical range here in the Piedmont. So having this base, FDR base, gives us 8 inches of base as strong as asphalt base, almost, because the structural number for FDR is about 0.26. For the asphalt base course is 0.3. So that's great value to a section here in the road, and we not only were able to mitigate the potential crack, reflective crack issues that we could have had if we only made fuel, but we extend the pavement service life because FDR can overlay with a minimum of 2 inches of asphalt can last 20-25 years without any additional treatments on it. So that's an additional testing that would benefit decision making after the FDR was already selected as a treatment or rehabilitation rather method. The additional pavement testing technologies, methods that most of you probably know, they're specific and more targeted towards the heavy loaded roads, such as arterial or truck bus routes. And specifically, falling weight deflectometer is when the designer or the engineer, the municipality needs to know structural capacity or structural design life. Fully weight deflectometer assists in making decisions about the current structural capacity and what has to be done to achieve a certain structural design life. Another equipment and tool is ground penetrating radar. Ground penetrating radar is used in many engineering applications. One of them could be for transportation and pavement with different types of antennas to mainly find or determine estimate pavement thickness. So I'll talk a little bit of this. As I mentioned, these tools, this equipment is for specific applications, not for municipal roads, but if you have a bus route or truck route that's, it might be a mile long, but because the roads are so heavy, it gives you a constant maintenance issues and repairs that cost a lot every year. Structural capacity might be something that needs to be evaluated to improve and increase the capacity rather than keep patching or keep doing not exactly appropriate measures if the capacity is not enough, structural capacity. So FWD or falling weight deflectometer helps mainly with overlay thickness when we want to have I see we're kind of running out of time here. So through back calculation or different engineering calculations, you can basically tell, you can estimate what overlay you need based on pavement response of the FWD walls. This is an interesting graph here that shows FDR, and that was tested. A road which was FDR was tested with FWD, falling weight deflectometer before. On the left-hand side is FDR, and right-hand side is nothing was done. So it was tested in 2016. This is the response, which is pavement deflections. And in 2 years later, was tested again. And the response is basically deflections go really low where FDR was applied. And the deflections go a little bit higher where there was no FDR, nothing was done. Low deflection means high strength. High deflection is low strength. So that shows the benefit of FDR here. Another tool is GPR, which gives you pavement layer thickness of asphalt base course, and it can give you nice covers here, cover map to see what thicknesses there are in different road segments. Constructability is very important when we do resurfacing. Is it feasible to do this resurfacing with this 2 inches, 3 inches? Is it feasible? How the construction method will impact residents? Will construction be considered based on curb and gutter, as we showed in this animation previously? And what is the utility that do we need to be careful about utilities? Sometimes asphalt lift thickness has standards that we need to consider. Will lane closure impact residents? How much lane closure can we allow? And does the base upgrade needs repair? Is it suitable for different types of pavement applications? And these are some photos of same project that I talked previously, how sometimes what we need to consider in constructability is inlets, depth, driveway elevation, and even tree roots. That's the utilities. Sometimes we need to have in mind the utilities work has to be done before the payment, and that's the utility corridor that Steve talked about earlier. That is common assets corridor. So with that, with all this information, we can make better decision for optimizing budget and schedule, apply current design standards, pick the most benefit cost alternative between different payment treatments, so payment rehabilitation methods, and some of the things that I talk about. How deep do we need to strengthen the subgrade, and do we need more structure? Some other new applications of materials and methodologies. Fiber reinforced asphalt surface is common now. Geogrid or geotextile can be applied both on the subgrade and base course, as well as in between asphalt layers, fiber reinforced polymer pavement interlayer for mitigating reflective cracking. Some new methodologies for construction could be dustless to mitigate residence interruption and disturbance. Cold in place recycling is a very good method to both remove the cracks and use the existing pavement thickness and section. And there's some other possible concrete applications here, such as white topping and roller compacted concrete for heavy walled sections. And we all want to achieve this to see before and after with these programs are the most efficient and effective way. Thank you.
Alrighty, we are just out of time. Someone asked, what is dustless FDR construction? Real quick.
So when FDR is constructed, when you apply the cement, there's typically quite a bit of dust coming out in the air. And in order to use this in some urban conditions where residents may not be very receptive to this dust, there's new dust less with less dust application of FDR, which I'm not that familiar with, but we are discussing here at WithersRavenel with contractors to get more familiar with it and start talking with our clients about it.
Awesome. We are out of time. Vlad, thank you for presenting today. Everybody, thanks for attending Lunch and Learn. So our next Lunch and Learn will be in February. It'll be on traffic control innovations. And I know I said that in December, but we're going to have it this time. Mark Blanton, who is a work zone safety instructor with JMT Engineering. He'll be giving the presentation. That's going to be on Wednesday, the 28th at 11:30 a.m. And you will be receiving some emails on that. So anyway, I hope everybody has a great day and we'll see you next time. Thanks.